and socioeconomic variables. Okay, so land use variable, what is the land use? For instance, if it is zone number 1 residential zone, that's the land use. And the socioeconomic variables depends on the, we talk about that, the income of the people, age, gender, family size, car ownership. These are all socioeconomic variables. So we have, based on those variables, we can estimate how many trips is produced, how many trips is attracted in each zone. One of the models that we are using is called cross-classification model. So the cross-classification model relates these variables and estimate the number of the trips. So remember, is the trip generation model is a model that we have to calibrate for what is happening today and then use that for future. For instance, one way of doing it, we take for instance, we go to, let's say, a site such as McDonald's, and we try we try to find how many trips is coming to McDonald's and per 24 hours. So that gives you the trip production attraction on McDonald's. And then if you have a zone that is residential zone, and we try to estimate how many trips leaves that production zone to go to other activities such as fast food restaurants, schools, and so on. So we estimate that. So cross-classification model use these variables that we can use. Now, one of the cross-classification example model that I will show you is a model that's based on the family size, auto ownership, okay? So we take the survey and we try to find the trip rate, what's the number of the trips per household, and based on that, we forecast how many trips is going to be generated. I'm going to show you that model. Go to my pictures. Okay, so this is an example of cross-classification model, which is the home-based trip generation model. And now, when you're looking at this, let's say we have a zone, one area, and there are obviously different homes in this area. So we did a survey of those homes. We went and knocked. I show you how we collect the data. One of them was for home interview, as we talked about before. So we went and asked each of these houses that, for instance, how many people live in that house? So that will be our family size here. So some of them, they said that they live there's one person in the household. Some of them, they said there are two persons in the household, 3 or 4 or more. So that was the number of households. And then we asked them that, how many trips do you make per day? Okay. So they told us, let's say 1 trip or 2 trips or 3 trips. Each of them said different thing. And we asked them that, how many cars do you guys have? So some of them, they said that they don't have any automobile, 0 automobile. Some of them, they said they have 1 automobile. Some of them, they said they have 2 or more auto. So we collected all those data and arranged it according to this table. So based on our survey that we did, we found out that 925, which is here, 925 of these households had no car. So they are in that category, no car. And when we added the number of the trips that they made overall was 1,098 trips. So 1,098 trips were made by household that had one person in it, and they didn't have a car. So you read this table accordingly. For instance, if they had a car, we found that 1,872 of these households have one car. And then the total trip that they made was 4,821 trips. Right? And then the same thing, one person in the household, there were 120 of them that had two or more cars. And the number of the trips they made was 206 trips. So you read this table this way. So we collected those data and we brought it and arranged it in this table such as what you see. So for instance, for two person in the household, if they said we are two people in the household, they made, there was 1,900, no, 14, whatever it was. Let me erase that and see. Okay, 1,471. And the total trip that they made was 2,105. And so on. That those people they had no cars. So there were two people in the household with one car, 1934, and they made 6,129 trips, and so on. Does everyone understand this table? Anybody has a question on it? Okay. So this is when we collect the data in that zone, we found these trips and these number of households arranged by family size and car ownership. Now, one thing we like to do by cross classification, we like to find the trip rate, which means what? We like to know how many trips per household per day. We call it trip generation rate. So we like to have a trip generation rate, which is here, which gives you number of the trips per household per day. So again, we have auto ownership, which is 0, 1, 2 or more. We have a family size. For instance, a person that's single in the house and have no car, on the average, they make 1.19 trips. Where do we get this number? Where do you get 1.19 trips per household per day?
Do you divide the number of trips by the number of households?
Yeah, that's it. So we divide 1,098 by 925 in that category. So we get 1.19, right? Everybody get that?
Yeah, correct.
Okay, number of the trips divided by number of households give you the trip rates, which is the number of trips per household. So we do it for each of these categories. So 1.19, 1.43, 1.45, and so on. So that's how we get these numbers, correct? So that gives us, on the average, how many trips each of these categories are making per household, per day. Now you have to tell me this. If you look at the data, it shows that if you have no car and if you are one person, on the average, you make 1.19 trips. If you have a car, which is one, you make 2.5 trips per day, almost 2.57. But if you have two or more car, you make 1.17 trips. Why you make less trip if you have two or more cars? Do you guys get my question? Number of the trips means that you leave your house, you go somewhere and come back.
You don't use all the cars?
Just one trip. Every time you leave your house and come back, that's one trip. Now, if you have no car, on the average, you go out only one time, 1.19. If you have a car, you're encouraged to go more. So you go 2.5 trips. Well, why it goes down as you have two or more cars?
Is it because everyone's sharing one car? And with more than two cars, everybody has their own car?
No, you are only one person in the household.
Ah.
There's only one person in the household. So why, if you're a single person in the apartment living, if you have no car, you make 1.19 trip. If you have one car, you make 2.5 trip. Why you make less trip if you have two or more car?
Shouldn't drive as much as having one car?
You know what I'm talking about? Number of the trips that you leave your apartment and come back. What is to do with number of cars you have? You can have 5 cars sitting in the parking lot. You say, well, because I have 5 cars, I stay home. Or you have 2 cars, you stay home. Why is that?
You can leave your car somewhere.
Pardon?
Maybe you make one trip because you leave it somewhere for the day.
No. I'm talking about the number of the trips you make. Okay, try to understand that. Number of the trips that you make. For instance, you come to school and you go home. That's one trip. And you use one car to come and go. Why, if you have 2 cars in your apartment, you make less trip? You have to come to school, so you make a trip. Why you make less trip if you have 2 cars? Anybody can tell me the reason that why we have lower number? Doesn't matter carpool or not carpool. That's still a trip.
Could it be because maybe if you have 2 cars, if one of your cars breaks down, you don't have to make a unnecessary trip to go get it fixed immediately?
No.
So if your car needs gas, right, you'll go out and put gas on it. That's one trip.
Yeah, but that's not reducing your number of trips. Look at the data, see if you can recognize why.
Is it because there's less houses with one or more, with 2 cars or more?
Yeah, the sample size, you know, when the sample size is small, anything can happen. So if, for instance, because we have only 121 households that making or having 2 or more car, one person. So it could be just 5, 10 of those people are retired. They never even go out. Okay? Since sample size is small, anything can happen. If 10 people don't go at all outside or making a trip, that influences the average. But if the sample size is large, that doesn't influence it. So it's something to do with the sample size. The sample size of this category is very small. So anything can happen. But when you have 4,821 trips and 1,800 household, that's a large sample size. So that goes to the average. So if 10 or 20 or 100 of them are acting differently, totally, it doesn't affect the average that much. That's the reason. The statistics works only if your sample size is large. All right? Does everyone understand that? Okay. Now the same thing happened on 2 people. If there are 2 people in the household, then if you have no car, you make 1.43 trips. If you have 1 person in the household, and 2 person in the household, 1 car, 3.16. But 2 or more is less. Again, that's another reason, because if you look at the sample size compared to the other one, this sample size is small. 692 versus 1934. So that's why you have different number. It could have been larger, but it is not. Okay? But when you get to the 3 or 4 or more, you see that makes sense. Why? Because your sample size is large. So when you have 2 or more, you make more trips. Any question on this? Okay, so what happened is that we collect the data on the number of households on each category, and when we divide the number of trips over number of households, we get the trip rate, which we just have it here. Now, what do we do with that trip rate? Let's assume that we have a development or a zone that we know what is the family size and the number of households in that zone. So if we have this zone and we know the household in each of these categories, we can forecast how many trips they're going to make. For instance, sometimes we use even buildings. Let's say we have a high-rise building here. That's already, we know how many apartments are there, how many people living in each of those apartments, and whether they have a car or no car. So we want to build another one right beside it, which is similar to this. So we can say, take this data, which is here, and based on that, we can estimate how many trips is going to be generated by the new building. So we know, for instance, that in that previous apartment, that there are 24 apartments with single person in it and no car. We know that there are 42 households with 1 car and 1 person in it, and so on. So when we have this data, which is the forecasted data, we can figure out how many trips is going to be generated by that zone. How can we find the generation on this case? What do? So we have the number of households in each category. How do I find the number of the trips, total trips that's being made on each of these categories? So what's the answer? We have this table, forecasted. How do I find the number of the trips? These are the number of households. How do I find the number of the trips? Anybody? Do you guys understand the third table? I need your participation.
I don't understand how they got 24.
What?
Said I don't understand the third one.
The third one, it just gives you the number of households we forecasted. Let's say we have in the zone, and we forecast that in this zone, there are 24 households that has no car and one person. 24 of them. There are 10 of them that have 2 people in it and no car, and so on. So all these households that we have here, we categorize it on whether they have a car or not, or with how many people are living in the household. So we got the numbers. So these are the number of households. 24 is the number of households with no car and one person in the family. Now, how many trips that category makes based on the data we have?
Household times the trip generation rate.
Yeah, that's very simple. So we multiply 24, which is on this category here, by what? By 1.19, correct? This is the average number of the trips that in this category is being made per household. So we have 24 households. They are making 1.19 trips per household. So when we multiply them, you have 29 trips. So there are 29 trips on that category. Everybody understand that?
Yes.
And now you multiply all these numbers. For instance, the next one will be 10 times what? 1.43, correct? And you end up with 14 almost. 14 trips being made by a household that has 2 people in it and no car. So what you have to do is you have to multiply all of these numbers by the trip rates and add them up together and find out how many trips being made. Any question on that? So if we do that, we are going to end up with all of these. So we're going to end up with 29 trips on the first one that I calculated. We're going to have 14 And we're going to have 16. And we're going to have 6. So I write it here, 29, 14, 16, and 6, correct? That's for this column. The next column is we multiply 2.57 by 42. So that will be 108. We multiply 3.16 by 51. You get 164. And we get 141. And we get 75. And then we end up with 14, 232, 749, and 1564. So what would be the total on the column? 65. 488 and 2559. And then we have 151 on the row, 410, 906, and 1645. So what would be the total? I write it here, 3,112. Total number of the trips. If you add the column and the last row, you get that. So that's how we find the total number of the trips that generated. Now, if I have a question, I tell you, how many trips are being made by household that has one person in it? Household that has one person in it. How many trips is being made?
151.
151, correct? We don't care whether they have a car or not. All the household that there's one person in it is 151 trips. If I ask you how many trips is being made by household that has one car,
488.
488, right? One car, 488, and so on. So you can answer those questions, correct?
Yeah.
All right. Everybody understand this? So on cross classification, we collect the data, we find the trip rates. And once we find the trip rate, we multiply the trip rate by the number of households forecasted in that zone. Forecasted means that what would be the number in the future. So if you have those households in the future in that zone, we can figure out how many trips they're going to make overall. So that's cross classification method. And I show it by table for you to understand. Any question before we leave this page?
Is this page on the book or is it on Canvas?
No, actually, I have not put this one on Canvas. I can put it, that's no problem, this table.
Okay, thank you.
Yeah. All right, any other question? All right, but your book is not showing it by table, it shows by graph. And those graphs are developed by Federal Highway Administration to estimate the same thing, how many trips is going to be generated. And I will show you those graphs now, which is in your book. Okay, any question before I leave this page? Okay, so let's go over the graph. All right. This is the graph I'm talking about. That's on page 267 of your textbook. Of your book. Okay. Let me show you what this is. For instance, the first graph is show the average zone income. That's another variable that we can use in socioeconomic variable. I told you about income, gender, auto ownership, family size, and so on. So here they are using the average zone income. So if you have an area or a zone, you know what the average income of people are in that zone. So let's assume that you have so many, some average of the household, let's say, $50,000, for instance. So use this graph and you go up and you intersect here, you intersect here, you intersect here. So what do we do with that? We go across and find the percent of household in that group. So we like to know what percentages of the people are in the low income, what percentages are on medium income, what percentages are in the high income in that zone. So we get the percentage of household in each group. So it could be, let's say, 20% are low income, 40% medium, and maybe 40% or 60% high. Total should be 100%. Okay, so this graph show you the percent of household in each group. Any question on that? All right, the next graph this is the next graph. Again, we get the household income, whatever it was, and then we do the same thing as we did before. We try to find what percentages of those households that have no car, what percentages have one car, what percentages have two or more cars. So we get a percentages of maybe 10% have no car, maybe 30 or 40% have one car, and 40, 50% have two or more. So from this data, from this curve, we find the percentages of auto ownership. Any question on that? If you multiply that, so if you have a percentage of auto ownership, and if you multiply this by the number of households, okay, you can figure out what are the number of auto ownership in that group. percent of auto, let's say there are 1,000 people living that, let's say 1,000 people live here, correct? If 10% of them have no car, so 10% of 1,000 will be 100 household with no car. 200, maybe 400 with the one car, and so on. So if you multiply these by number of households, you can figure out the number of auto ownership. Okay, any question on that? The same thing here. When you have a percentage, if you multiply that the number of households, then you can figure out how many people are in the low income, how many people are medium income, how many people are in high income category. All right. Any question? Now, the next thing we want to do is go to the next graph. That's on next page of your book. Okay, so that is okay, these are this graph. Now, here you can find the trips per household. You remember trip rate that we found by those tables? So again, if you use a household income and you go up, you find the trip rates. These are the trip rate per auto ownership, which we had it in the other table that I show you. So this gives you the number of the trips per household. So these are your trip rates. Then the next thing,
quick question.
yes.
So how are you making the line right down the middle or on a real?
No, actually you have to look at, you have to see a zone and you have to see what's the average income.
Oh, so like on a real problem, there's gonna be
the average income. Usually these are scaled. These are scaled, okay. Let's say 0 to, $100,000 income.
And then you can give us what value to look for. And
so if the 50,000 income is right here in the middle or whatever.
Oh, okay. Okay, now it makes sense. Okay.
Yeah. Okay.
Thank you.
All right. Then the next thing is this graph. This graph is giving you percentages of the trip by the purpose. You remember we talked about the purpose of the trip? One was what? Home-based work trip, HBW. That means people who are starting at home and going to work. Home-based work trip. People start from home and come from home and go from home to work and then go back from work to home. Those are home-based work trip. So again, when we put the average income and then you try to figure out what percentages of those trips are home-based work trips. We've tried to figure out what percentage of non-home-based work trip, non-home-based. Non-home-based means what? Means your origin or your destination is not home. That's a non-home-based trip. For instance, from work, you go to bank and you go back to work. Or go shop, go back to work. From school, you go to bank or you go shop, you go to bookstore and you come back to school. Those are non-home-based trips. And then we have home-based other, HBO. We try to figure out what percentage of those trips are starting from home, but going other places like banks, shopping, visiting friends, not work. So those called HBO, home-based others. So pretty much you break down your trips on these purposes. What percentages are these? So again, if you multiply those by the number of households, you can figure out what are the number of the trips that's being made by each purpose. So use these graphs that is being developed by Federal Highway and being used to figure out the trip generation. How many trips is being produced or attracted. So these, both of these that I show you called cross-classification method. So cross-classification method, simply, you try to find the trip rate and multiply the trip rate by the number of households. That's all it is. And to figure out how many trips is being made in each category. Now, this graph show you the number of the trips per purpose, the purpose of the trip. The other one that I show you on the table was all together, was not by purpose. Any question on cross-classification method? The shortcoming of this model is that it's difficult to forecast. So if you have a zone, so it's very difficult to figure out that in the future, let's say 25 years from now, how many family size will be with no car, one person in it, or one car, one person, or two person in it, and two cars, and so on. So that's a tough one to estimate. So that's the shortcoming of this model. Forecasting that is very difficult. All right, so that's the first model in trip generation. Now, there's another model that we use more often, and we call it ITE. That's the second model, ITE trip generation model. ITE trip generation model. What's the ITE stands for? ITE stands for Institute of Transportation Engineers. Institute of Transportation Engineers, or we call it ITE. It's like ASCE. It's a student organization we have on campus too. We call it ITE Student Chapter. You can be a member of it. The ITE does a lot of things. Publishes book. Okay, does a lot of modeling. And one of the things that they do, and they have conferences like ASCE, student chapter everywhere, international conference, domestic conference, division conferences. So it's like ASCE does a lot of things. And they have over 100,000 members worldwide. So anybody who's interested in transportation, they get to be a member of ITE. So one of the publication that ITE has is called ITE Trip Generation Manual. This is a manual, I'm sorry. Trip generation manual is actually a very thick book, big book, where all the trip generation rates are there. Remember, in order to get the trip generation rate, we had to go in a zone and collect all these households, how many cars they have, whether there are one person or two person in it, and so on, to get the trip generation rate, which was the second table. How many trips per household is being made? ITE had done all of that. So they publish it in the book. For instance, I can go open the book. I am interested to, for instance, to find out if I have an office building here, I like to know how many trips is going to be generated by that office building. So I go open up the book and go to the section, say office building. And they have a different size of office building, less than 50,000 square feet, between 50 to 100,000 and more than 100,000 and so on. So I go to the right size and they have this type of a trip generation rate for me. So here is the office, for instance. So they have an AM peak. They have a PM peak. And they have daily. So on the AM peak, they have the number that goes in the office building and the number that comes out of office building. So we have an inbound and outbound. And then in PM, we have the same thing, inbound and outbound. And then we have a daily. AM peak is what? It's between 7 to 8 a.m. usually. PM peak is between 5 to 6 p.m. So if I go office building, let's say with 100,000 square feet, they give me how many going in between 7 to 8 a.m. we call inbound. How many coming out of that building between 7 to 8? So that's the inbound and outbound. And that is per 1,000 square feet. So for instance, I might have maybe 6, okay, going in and 2 coming out, which means what? This is per 1,000 square feet. So I have 100,000. So that means 600 going in and 200 coming out. Does everyone follow me? Because these numbers that they have is per 1,000 square feet. So that means 6 people or 6 trips goes per each 1,000 square feet. So we have 100,000. So that will be 6 times 100. So 600. And 200 coming out. And on the PM peak, you might have, again, 3 going in and 8 coming out. That means 300 going in and 800 coming out. And then we have a daily. So you might have, let's say, 22 daily. That means 2,200 people making a trip going in and out. So this is a table that you read from ITE Trip Generation Manual. And this is only for office building. But this manual is hundreds of pages. So anything that you can think is there. For instance, you can open up a page, they say restaurant. They have different types of restaurant, fast food restaurant, and seating restaurant. And then they have different size. So you can find the trip generation rate for each of those. For instance, fast food restaurants such as McDonald's, Burger King, and so on. They have a trip generation rate that you can figure out how many trips going in and out. So if I'm building a McDonald's, which is 1,000 square feet, if I go to the trip generation manual, I can figure out how many trips going in the morning into that McDonald's, how many coming out, and the same thing in the afternoon. Where do they get this data? Well, they have gone to maybe 1,000 McDonald's, stand by the door, and collect the data between 7 to 8 and 5 to 6 p.m. So they did those collection, and then they found the trip rate. So this trip generation manual has a very large data, therefore is more reliable than any other trip generation rate that we can do, because they go for a very, very large data set. So any activity that you can think of, even car repair shop, you can go in and see if you have a car repair shop of 2,000 square feet, how many trips is going in and out, and so on. Theater, shopping centers, even schools, universities, they have all these, any type of a development that's happening, they have a trip generation rates on it. Even if they don't have one that they might have not got the data, they usually put it as a contract for people to gather the data and find the trip generation rate on that. And most of the analysis that we do, almost 80 to 90% of the modeling that we do, we use the ITE manual. So if you go to any traffic engineering consulting firm, or even go to the city or state, if you go to that division of the planning, you will see that they have this book on the table because they use them all the time to forecast how many trips is being generated. Remember, I mentioned that we use this for traffic impact report. You cannot develop any land unless you write a traffic impact report. And those traffic impact report, the first step is find a number of the trips is produced or attracted. So to get that, we got to use the trip generation model. And this trip generation manual by ITE is 80%, almost more than that, we use all the time. Although sometimes some cities say that I don't want you to use ITE trip generation manual figures, and they have their own. So for instance, they might have, instead of 6, they might have 8, then they might have 4 here and so on, because they think that there are more people going in and out, and therefore they have their own numbers that you have to use. I did work for City of Santa Monica and one time City of San Diego. And I had to use their trip generation rate that they gave it to me. But those are the one that we use always in this type of analysis. Any question on this? Does everyone understand it? And a lot of time you can even Google and find what is the trip generation rate, for instance, for office building of 100,000 square feet. It goes to the trip generation manual and get the number for you. You even can do that. Because I teach advanced class of this planning, which is 5750. And we do a lot of analysis. So we use the trip generation manual. So students usually Google to find those rates. Because the book is costly to buy. Although now they have the book on the CD, you can buy the CD and just get all the trip generation rates on one CD. Okay, so that's the second method that we use for trip generation. I encourage you to look at the video that I put in and watch that trip generation that they discuss on that video. So they talk about this. All right. Now, what would be the third method? The third method is regression model. The regression model is basically relate the number of the trips to some of those variables. When we collect the data and we plot them, for instance, if I say the number of the trips generated, at the y-axis, and I say income as the x-axis. So if I go collect the data, I will have different income will be using different number of trips. So we'll have different number of the trips or different income. If I go to one zone and collect, and I ask people that how many trips you are making, and then what is your income? So I collect that data and I come and plot this. So each of these will show you what's their income and how many trips they make. Now, what the regression does, we try to fit a line through these data that fits the best. So for instance, if I draw a line like this, it balances these. And if I write the equation of this line, that will be my model. So graphically, if I just extend this, I could find my intercept. So my intercept will be A. And if I know the slope of this line, which is B, I can write the equation of this line. So I will write here y equal to A plus bx. Okay, so that gives me the number of the trips increases as the income goes up. And this will be the model. So your X is income. And Y is the number of the trips. Now, A and B are unknown. Which I have to estimate. So this is what we call regression. To estimate A and B graphically is easy, you can measure it. But mathematically, I have to show you how to do that. Now, if there is one variable, X, we call it simple regression. When we have Y equal to, for instance, A plus B1 X1 plus B2 X2 and so on. More variable. X1 could be income. X2 could be auto ownership. X3 could be family size. All those variables that we talk about. This is called multiple regression. So we have a simple regression, which is only one variable. And we have a multiple regression, which we have more than one variable. Now, if they ask you, what do we mean by calibrating or estimating? Regression model. If they ask you this question, what's the answer? How do we estimate or calibrate a regression model? Well, if they ask you this question, you have to answer, say, estimating the unknown. That's what we are doing. Okay? What are the unknown? Which I just said that here. A and B. Those are the coefficients that we have to estimate. Multiple regression, we have to estimate A, B1, B2, and so on. So that's what it means by calibrating a model or estimating a model. Always, if they ask you this question on any model, you have to say estimating the unknown, which is A, B1, B2, and so on. Now, estimating these mathematically, we will do that next time because it takes a little bit of time, and find out how we can estimate the regression model and how I give you an example of those two. Okay? Regression model is used for major planning. For instance, if you go and work for SCAG, which I mentioned that before, which is Southern California Association of Government, which is in downtown LA in the 8th Street. If you go work for them, which they are in charge of all the planning of Southern California, you see that they constantly using regression model for the trip generation because it's a huge area and they don't use those ITE trip generation rate that I talk about. Those mostly are used for just planning or writing traffic impact report or small areas and so on. But when you're looking at the very large area, you have to use a regression model. And that's what they are using. And that's what their modeling is mainly. Regression model is very important, especially in your FE exam. They ask a lot of questions about regression model, which you should probably have had some exposure in your 2120, your statistic class. All right. So we're going to talk about least square estimation, which we are using that to estimate those coefficients next time. Any question before we leave? Okay. Study this regression model. And obviously you have some question that you have to put in if you have not put in yet. Any questions?